Okay, so we're naming things at this time, and I wasn't sure it would be up, so I loaded them on my iPad. I'm going to go ahead and share my screen. I hope that you have seen the videos from Monday and Tuesday, because the videos from Monday and Tuesday talk about like how we name ionic compounds. And so I'm going to jump in assuming that you have, and maybe you haven't. So I'm sorry if that's the case. And it will really help me if you will just ask questions if you have them. So the periodic table is divided pretty much into metals and nonmetals. And metals lose electrons to form cations, which is they've lost electrons, so there's more protons than electrons, and so they are positive. They're a positively charged thing. And then nonmetals gain electrons to form anions, and then we can put those together to form ionic compounds. And so this week, we're going to be looking at naming things that are ionic and covalent. And this handout starts with how we name things, and this begins with ionic things. So the first thing I would say is this handout is long. Oh my gosh, it's so long. I think it's 22 pages. Oops. And the second thing is you're not turning it in. And that's a little confusing. You want me to do all this work and not get credit for it? But you get credit for it when you learn it and then show it when you need to show it. And this week, the way you need to show it is on a lab called Nomenclature. It looks like this. And so this may look like, is this worth 20 points? It's so short. And the answer is, yeah. But in order to do this successfully without Googling, there's a lot of learning that is necessary. And that learning is given on this Nomenclature handout. It walks you through, just like the textbook does, how to do the things. So I have done 2 Zooms on how to name things. One says cations and anions. One says forming ionic compounds. That's just the beginning. You need to watch those. And then you'll work through this. Metals can lose electrons to become cations. Nonmetals can gain electrons to form anions. We put them together so that the net charge is 0. And this is how we name those things. And then I have some examples. And then we have some practice. And so I'm just going to jump in. The overview idea is this is just a little piece of something bigger that we're doing this week, and it takes practice. So watch and read and do everything. The second piece is this particular thing, this handout, which is very long, is not for points, but it is for learning, and the goal is learning. And for everything on this handout and the keys and worksheets page, I do have keys for these so you can check your work. And then when you check your work and it doesn't make sense, go back and look at your notes and see why that, if you can figure out why that doesn't make sense. And then when you see that if you can't figure it out, then we can Zoom. And so keep in mind that I am here, unless I'm in the park doing yoga or at Rayleigh's once every other week, I'm here. And we can make meetings, and the meetings don't have to last long. They just have to last long enough for you to get your questions answered. So the important part of being a student is doing the work, finding your questions and getting them answered. The goal is learning, and points follow learning. So don't worry about the points, focus on the learning. Okay, so I'm just going to begin in this handout to walk us through a few problems. Hopefully you have a periodic table nearby, because if you don't, this can be confusing. So go ahead and grab a periodic table. And I noticed that a lot of you have videos on, and I super appreciate that. Thank you very much. And the ones that don't have videos on, you have your reasons, and I totally respect that. That's not a problem. Okay, so the first part says, we're going to give the formula for, and then we have some examples. Lithium fluoride. So the first thing I need to do is find lithium on the periodic table and find fluorine and see what groups they're in. What group is lithium in?
1.
Okay. So when lithium forms an ion, what charge will that ion have?
+1.
Perfect. I'm going to write the +1 right above that lithium. Fluoride. Fluorine is in what group or column?
In the halogens.
It is a halogen, which is group 7. Halogens are nonmetals that gain electrons. How many electrons will it gain to become stable?
9.
I'm curious, why did you say 9?
To become stable, for it to be an atom, I'm sorry, I'm thinking atom.
It has 9 as an atom. That is exactly right. How many electrons would be better than 9?
10.
Yes. So it gains 1 electron and has a -1 charge. Good. So here I have lithium ion and fluoride ion. To come together in a 1-to-1 into a ratio that adds to 0, how many lithiums and fluorides would I need? 1 and 1. So I'm going to combine those and write LiF. That is the formula for lithium fluoride. Lithium fluoride is an ionic compound. It's a whole bunch of lithium ions and fluoride ions that are stuck together in a way where every positive ion, cation, is right next to an anion, a negative ion. But if we just look at the smallest unit that represents that ratio, it's 1-to-1. Now, we don't write lithium 1, fluoride 1, because in formulas, the ones are implied. But if it wasn't 1, we would write that number. Okay, beryllium oxide. Where's beryllium on the periodic table?
Group 2A.
I think it's element number 4, right? So things in group 2, the alkaline earth metals, when they form ions, what charge do they have?
+2.
Perfect. Oxide, where is that?
In group 6.
So things in group 6 want to be like things in group 8. How many electrons does oxygen need to gain to be like neon?
-2.
It needs to gain 2, and now it has 2 more electrons and protons, -2 charge. Perfect. And at any point, if you have questions, there are no wrong questions. All questions are good questions here. Okay, so when they come together in a 1-to-1 ratio, beryllium has a +2 charge, oxide has a -2 charge. It's still a 1-to-1 ratio, BeO, beryllium oxide. Potassium. Where is potassium? Keep in mind when we're looking at these, on the left, the element on the left is going to be found to the left on the periodic table. And ionic compounds always have the metal before the non-metal. So look on the left to find potassium. What group is it in?
1A.
So what charge would it have?
+1.
Perfect. Nitrogen. What group is it in? 5. And to get to 8 outside electrons, to be like neon, how many electrons would it need to gain?
3.
So it has 3 more electrons because it gained them, and protons, it has a -3 charge. Potassium ion is a +1, nitride is a -3. That may be a little confusing because nitride may not sound right. And the reason is, you will probably know the word nitrate. Nitrate is a real thing. Nitrite is a real thing. Nitrates and nitrites taste delicious. I love processed meats and cheese and wine. So nitrate and nitrite sound right because they are real things that you probably have heard more than nitride. Nitride doesn't sound right, but it is a thing. So here's a chance for us to focus on an idea that is important and will be important this week, and that is ides are nonmetals that have gained electrons, just an atom with extra electrons. But eights and ites have oxygens. And we will get to those this week. So nitride has a -3 charge. So we're going to need 3 potassium ions to balance that -3 charge. That's the formula for potassium nitride. Calcium phosphide. What charge would calcium ion have? Perfect.
2.
Yep. And then phosphorus is also in group 5. but needs to gain 3 electrons to become like argon. So here we're looking for the lowest common multiple. We're looking for the number that both of these multiply into, and that would be 6. So we're going to need 3 calcium ions, because the calcium is +2, to add to a charge of +6, the lowest common multiple, and 2 phosphides to add to -6. That's the ratio of cations to anions that make a total charge of 0. That formula unit represents a larger salt of calcium ions and phosphide ions. Okay, so calcium phosphide is also a word that sounds wrong. Why, instead of phosphide, what would you like to say?
Phosphate?
Yeah, totally. Me too. Phosphate is an oxygen-containing anion, and so it is a different ion that is real, and we will deal with this week. Ides are just, we have 1 nonmetal and extra electrons, and 8s and ites have oxygen. So phosphate sounds right, but phosphide is the right answer here. There's going to be times in this class, especially when you start talking about naming things like acids, you feel like, oh, that doesn't sound right, but it might be right. So you have to kind of let go of what you know is normal. Those things are real in your real life, but there is more than that. Okay, so calcium phosphide ides have no oxygens. Calcium phosphate, which is real, has oxygens. Calcium phosphite has oxygens. Okay, aluminum sulfide. Aluminum is in group 3. Sulfur is in group 6, so it has to bring 2 electrons to be like something in group 8, which is argon. And then we want to put them together in a ratio so they add to 0. The lowest common multiple here again is 6. I'm going to need 2 aluminum ions to get to +6, and 3 sulfides to get to -6. We put the cation first and the anion second, just like they are in the periodic table. The metals on the left and the nonmetals on the right. And then I'm just going to count 1, 2. There's 2 of those. And 1, 2, 3. There's 3 sulfides. Oops. Aluminum sulfide. Okay, so for the next part, we're given a formula and asked the name. And thinking of that there's a lot of things out there, I'm going to walk through a thinking process that is more than we need at this moment. The first thing I'm going to say to myself is this an element or a compound? It's a compound. How do I know that? Because there's 2 capitals. There's more than 1 element, and there is no charge. That's a compound. And then I'm going to ask myself, is this ionic or covalent? We've only seen ionic so far, so the answer is ionic. But later this week, to answer that question, I would say this is ionic. It's ionic because the element on the left is a metal, and metals form cations. And on the right, we have a nonmetal, and nonmetals form anions. So cations plus anions mean ionic. And for ionic compounds, we just say cation name, anion name. We drop the word ion and we add an ide. So this is sodium bromide. The cation name is sodium ion. The anion name would be bromine, but when it becomes an anion, this part changes. Oops. This part changes to ide. And then we would have the word ion, but we drop the word ion. So sodium bromide is the name for that. For the next one, we have magnesium and oxygen. And the first thing I say is this an element or a compound? It's a compound. How do I know? More than one capital, no charge showing. Is it ionic or covalent? It's ionic because it begins with a metal. What metal is that? It's magnesium. And the anion is oxygen, but anions where the element gained electrons are ides. It's oxide. So go ahead and do the next, you do the next three, or you think of questions and ask them, and then I'll do the next three in a minute. Go ahead.
Sue, can you go over the ide one more time?
Sure.
I thought the ide was when there is no oxygen.
It is. But when there's extra electrons. So, yeah. So here we have some nonmetals.
Mm-hmm.
And these are the nonmetals that are going to gain electrons. And when they gain electrons, so here, let's look at nitrogen. When nitrogen gains electrons, how many electrons does it gain?
3.
To become isoelectronic with neon. And when we put those extra 3 electrons on there, the ending of that name changes. It becomes nitride. So the ide ending means it has extra electrons. The atom that is a nonmetal has extra electrons. Let's do that again. Here we have bromine. But when bromine gains 1 electron to become isoelectronic with krypton, the name changes, bromide.
Mm-hmm.
So the ide ending means no oxygens, but there are some extra electrons. Now, when is that not true? Oxygen. So when oxygen gains electrons, it becomes oxide. And it contains oxygen because it is oxygen. Did that answer your question?
Mm-hmm.
Okay.
Thank you.
Oh, you bet. My pleasure. Okay. So here we have potassium. And it was potassium ion. And it combined with sulfur that had gained electrons, so sulfide. And so we needed 2 potassiums to balance that -2 charge of the sulfide. But we don't need to say that because people that have a periodic table just know potassium's in group 1, +1. Sulfide's in group 6, -2. And so people will put that together in their head and know that this is potassium sulfide. We don't say how many of each kind because once we stated the ion, people can put those pieces together themselves. I mean, not yet, we're new. In a week, you'll know there's 2 potassium ions for every 1 sulfide because the charges, which are based on position on the periodic table. Okay, the next one, the first thing I ask myself in my flow chart of thinking, not this week, but by the end of the week is this an element or a compound? And the answer is it's a compound. How do I know that?
2 capital letters.
Perfect, no chart showing. So this, not a compound. This, not a compound. This, oh, that's a compound. 2 capital letters, no charge showing. Okay, and then I ask myself, is it ionic? Which means, does it start with a cation? Do we have a metal present? And the answer is yes. Beryllium is a metal. Okay, we have an ionic compound. Beryllium is an alkali metal, so we know what its charge is. What's its charge?
2.
Plus
Wait.
2.
Plus
If it
2.
was in the unknown zone, we wouldn't know the charge. That would have to be stated. But beryllium is a plus 2 ion. And then there's phosphorus, but no oxygen, so we're going to call it phosphide. So we don't need to say anything about this 3 or this 2 because people with the periodic table know beryllium ion is a plus 2, and phosphorus, when it becomes an ion, phosphide is a minus 3. And so they understand that we're going to need 3 berylliums and 2 phosphoruses, phosphides, to make this compound. So this is just beryllium phosphide. Okay, and then the last one. What do you get?
Aluminum chloride.
Perfect. You didn't say 3 chlorides. Why? Because it'd be wrong. Because you didn't need to. People know that aluminum with a periodic table, they can know it's plus 3 and chloride's minus 1. Perfect. Okay, so the next one is not really turning out for me. It looks better on the page that you probably downloaded. But here's what we're going to do here. Is we recognize that the cation comes before the anion, and we put them together in a ratio where they add to 0. So plus 1 minus 1 plus 2 minus 1 means we're going to need 2 chlorides to balance that zinc charge. So the goal of this table is just to put cations and anions together in a way that they add to 0. And then to also remember that the metal, the cation, comes first. Let's go ahead and do this one. Let's put aluminum ion together with sulfur, and it'll go in box number 7.
Aluminum 2, sulfur 3.
Perfect. And how would you name that?
Aluminum sulfide.
Perfect.
No.
Yes.
Okay.
Yeah, that's exactly right. Does it bother you that you're not saying anything about 2 and 3?
No.
A little bit? No?
Not at all. No.
Awesome. Good. Okay. So here we're going to predict the chemical formula by the combination of ions. Put in the cation first. Remember that the formula should have a total charge of 0. That's why we have 2 aluminums and 3 sulfides, so that we add together plus 6 and minus 6 and equals 0 to make it a compound. And then give the name for each below. The other thing you need to remember is cations before anions, ladies before gentlemen, left before right. That's the order things go in, both in the formula and in the name. Okay. The formatting did not really translate well to my iPad, so please forgive me. Now here, and I don't even think, like it's missing things. I don't know what happened here. But for the first grid, I have posted an answer. But for all the other grids in the packet, there are answers. You just have to go to keys to find them. Okay, so some ions, generally transition metals, have more than one stable ion. So we have to state which one we're talking about in the name. And the example I gave was iron 3 chloride, which is different from iron 2 chloride. So where would you find metals that have more than one possibility, charge possibility?
Is that in the unknown zone?
Yeah. And that's right here. And so for iron, you have to be told if you're working with iron 2 or iron 3. Now, most elements in the unknown zone have more than one possibility. Some of them only have 2. And so in our class, and in Chem 1A, we focus on if they only have 2, there's this Latin system we use also. But just be aware that there are only a few that have fixed charge. Silver, zinc, and cadmium. And then your author talks about scandium, but we're not even going to touch on scandium in our class, so don't even worry about that. And then you know things in group 3 would have a +3 charge. So a way that you can remember that silver is always +1 and that zinc and cadmium are always +2 is by just recognizing there's sort of some stair steps here. And the first one has 1 stair, +1. The second one has 2 stairs, +2, 3 stairs. Those are fixed charges, which means we don't state the charge because there's only one possibility if it's not the atom for the charge species. But there are some that have more than one charge choice. And in our class, those are going to be 10 in lead, can be 2 and 4. And you don't have to write this down because it's on that page. Chromium, iron, cobalt can be 2 and 3. And then copper and mercury, it says Mg, it should be Hg, can be 1 and 2. So there are some that have have more than one charge choice. And so here it says the exceptions are silver only forms a +1, so you don't state the charge. In fact, if you state the charge, that makes it wrong. And then zinc and cadmium can only be +2. You don't state that charge. So here, when I'm looking at this particular compound, the first thing I say is that an element or a compound? It's a compound, more than one capital. Is it ionic or covalent? It's covalent because cobalt is a metal. And then we look on the periodic table. Where is cobalt? It's in the unknown zone. So for cobalt, we're going to have to state the charge. I know that this is cobalt chloride, but I need to say which cobalt. Well, if there's 3 chlorides, and cobalt has to balance that charge, it must be cobalt 3. So I write a Roman numeral 3 inside parentheses behind the cobalt. And the 3 here is representing the charge on the cobalt ion, which is +3. Cobalt 3 chloride. If I just said cobalt chloride, it wouldn't be clear because cobalt has 2 choices, +2 and +3. So here we have some more. And the trick is, some of these are fixed charge. There's only one possibility, so don't state it. And some of these are variable. And I just mentioned that zinc and aluminum can only be certain things. What is the fixed charge that zinc ion has?
+2.
So we don't say zinc 2 chloride because the only choice would be 2. We say zinc chloride. How about silver?
+1.
Because it only has one charge choice, we don't state it. We just say silver sulfide. And people who have a periodic table and understand chemistry know that means 2 silver ions for every 1 sulfide based on charge. But for manganese and chromium, there are charge choices. So we have to figure out what the charge is. I know this is manganese oxide, but which manganese?
+1.
No, try again.
-1.
No, metals have to be positive. I love that you're talking to me. Metals have to be positive. So look at the oxide. What's the charge on the oxide?
-2.
-2.
Okay, and how many oxides are there?
1.
There's 2.
2.
Yeah. So if oxide is -2 and there are 2 of them, we have a negative forward anion charge. The cation has to balance that. This is manganese 4 oxide.
Mm.
1, Roman numeral 0, 2, 3, 4, 5, 6, 7, etc. So we're talking about this one.
Mhm.
We deduce the charge on a cation by looking at the anion and how many of them there are, and knowing that compounds add to 0. Okay, chromium phosphide. Which chromium phosphide? What's the charge on that ion?
2.
Yes. There's 3 of them. Oops. And phosphorus, as phosphide, has a -3 charge. There's 2 of those, which adds to -6. So yeah, it must be chromium 2 or it wouldn't add to 0. Okay, and then here we have, it says cations with a variable charge, and variable charge means more than one possibility, so you have to state it. So everyone that involves this copper is a copper 1 something. Copper 1 bromide, copper 1 oxide, copper 1 phosphide, copper 1 iodide. Here we have lead 2, and so every time it combines with one of these ions, it's lead 2 that. Iron 3 is iron 3 bromide, iron 3 oxide, iron 3 phosphide. So the important part of this one is just know that because cations have variable charge, you state the charge. And then, so I'm not going to do the worksheet now unless you need me to. I'm just kind of giving an overview of how this works so that you can do it successfully. Do some work, find out what your questions are, and then ask them. And then here we have variable and fixed. So you have to decide, do I state that charge or not? If it's cesium, are you going to state the charge, cesium 1? It's in group 1.
No, I don't think you would state the charge, right?
Right, because it's only +1. The choices are 0, the element, or +1, the ion. How about 10? Would you state the charge? Turns out you do, because 10 can be +2 or +4. Cobalt, do you state the charge?
No.
Where is it on the periodic table?
In the unknown.
Transition.
Yeah. So you state the charge. Is it one of the exceptions in the unknown zone? Silver, cadmium, and zinc. So you state that charge. How about magnesium? You gonna state the charge?
No,
It's in the unknown zone.
No, magnesium is a group 2 metal.
yeah.
Maybe you're thinking of manganese. You know, people confuse those all the time. And this one too, mercury. Transition metal, alkaline earth metal, transition metal. Okay, so whether you state the charge or not depends on where it is on that periodic table. Do we know what the fixed charge is? Or is it variable? There's more than one choice. And then you're just combining things in a way where cation plus anion adds to 0, just like we did before. Okay, and then we get to some Latin stuff. For these ones, copper and mercury can be +1 or +2. Chromium, cobalt, and iron can be +2 or +3. Tin I'm sorry, lead and tin can be +2 or +4. For those in the old-fashioned times, they used some Latin nomenclature. And for the higher charge choice between the two, so between 2 and 4, 4 is higher, they would give it the "ic" ending and the other one the "us" ending. Between these, 2 and 3, they would give the higher one the "ic" ending and the smaller one the "us" ending. Between 1 and 2, 2 is higher, we call it "ic." And then we use the Latin root. So here we could say stannous chloride, which is the same thing as, oh, I'm sorry, it's the higher choice, 4. Let me try again. Stannic chloride, which is the same as tin 4 chloride. So we can either use the old-fashioned Latin way of doing it, but only for these, or we can name the systematic way. And if you have a choice, I would say use the systematic way. Systematic nomenclature is best. But the reason I mention this is you might notice in toothpaste, stannous fluoride. Stannous fluoride is the lower of the two charge choices for tin, which is 2. Or you might see on your vitamins, ferrous sulfate. And the ferrous just means iron 2. So it's just one of those things I'm not going to test you on, but you need to know when you see these weird words that there's a system to that too. Okay. There are some polyatomic ions, and you should memorize these. Now, at this time, you'll be tested, and you're at home, and you can have open notes, so you don't have to memorize them yet. But I still think if you memorize them, it will make your life better. Because tomorrow, I'm probably going to talk about like what we do with these. And there's ways that you can look at something like chlorate, and you can memorize chlorate, which I recommend you do. And once you know chlorate, you also know perchlorate, chlorite, hypochlorite, and even things about bromine, bromate, and iodine, iodate, perbromate, bromite, hypobromite. So there's a system of naming that we're going to use in this class, and whether you go on to 1A or 2A. And you don't have to memorize everything. If you have memorized chlorates, you will be able to derive all of these based on their position on the periodic table and a few rules. So you don't have to memorize everything. And by usage, you probably will remember some things. But you never have to memorize the periodic table. And you're never going to have to memorize some of these ions. You just have to remember 1 or 2 as a starting place for figuring things out. All righty, that's all I got for today. I'm glad that you were here. Nomenclature can be overwhelming because it's just work. You have to sort things out in your head. Nobody can do that for you. And I am happy to meet with you at different times. So if you just want to walk through some problems, it could take an hour or it could take 5 minutes, but we can set up a Zoom for that. And it can happen every day. Last semester, I had a student that needed to meet for half an hour every day for a week because the student just needed to get a grip on some stuff. And then they were successful. And that's okay. But I need you to reach out because I can't see you. I don't know if you're struggling unless you tell me you're struggling. All righty. That's all I got. Thank you for being here.
Thank you, Sue.
You're
Yeah.
welcome.